The question we are solving now belongs to test series 5. It is of control system subject. In specific, it belongs to Nyquist analysis. As per the question, the open loop transfer function of a unity negative feedback control system is given as g of s multiplied by h of s is equal to 1 minus 2s divided by s into 1 plus s. We need to find the gain margin of this control system in dB. We know that the gain margin of a control system is dependent on the phase crossover frequency, and at phase crossover frequency, the imaginary part of g of j omega and h of multiplied by h of j omega is 0. So for that, let us first find out g of j omega multiplied by h of j omega by substituting s is equal to j omega. So the given open loop transfer function can be simplified as 1 minus 2j omega divided by j omega multiplied by 1 plus j omega. So this can further be simplified as minus j into 1 minus 2j omega divided by omega into 1 plus j omega. Let us multiply and divide by 1 minus j omega so that only the numerator will have the imaginary part. So based on this quantity can further be simplified as minus j multiplied by 1 minus 2j omega multiplied by 1 minus j omega divided by omega multiplied by 1 plus omega square. Now in the obtained g of j omega multiplied by h of j omega, let us equate the imaginary part to 0. Upon doing the same, we see that the imaginary part, that is 1 minus 2 omega p square, should be equal to 0 because this value of omega p corresponds to phase crossover frequency. So from this, omega p is equal to 1 by 2 root 2 radians per second. So now let us evaluate the magnitude of the given open loop transfer function at omega p is equal to 1 by root 2. From this we see that magnitude of g of j omega p multiplied by h of j omega p can be written as 1 minus j root 2, that is 2j divided by root 2 divided by, this is the magnitude of this, multiplied by magnitude of j omega p, that is 1 by root 2, and multiplied by magnitude of 1 plus j by root 2. Now upon simplifying this, we see that the numerator is equal to root 3. Sorry, this should be j by root 2. Numerator is equal to root 3 and denominator is equal to 1 by root 2 multiplied by root of 3 by 2. So upon simplifying this, we see that this is equal to 2. So from this, we can say that the gain margin can be written as 20 log 10 apps of 1 by g of j omega p multiplied by h of j omega p. So we already got the magnitude of the denominator quantity that is marked here as 2. So upon substitution, we see that the gain margin of the control system can be written as minus 20 log 10 to dB. So from this we see that for the given control system the gain margin can be obtained based on the phase crossover frequency as minus 20 log 10 minus 20 log 2 to the base 10 dB. Hence the correct option representing the gain margin of the given control system is B.